All right, so today we add on our last kind of transformation. Remember the transformations we've already talked about: translation, reflection, and dilation. Today we add in rotation. We have rotations about a fixed point. Those fixed points are called the center of rotation. For us, I believe all of our centers of rotation should be the origin, or 0, 0. And we are also going to have an angle of rotation. Which tells us how much we rotate the figure. Our angles of rotation are going to be nice and easy. They're going to be increments of 90-degree turns. So 90, 180, 270, 360. Those are the ones we're going to work with. So if I look at a diagram, I'm going to determine the center and the angle of rotation. The center is usually just a point. So point C is the center here. The angle of rotation tells me how far around I'm turning. Remember, we are always going from the pre-image, which has no tick mark, to the image, which does have that little prime symbol. So make sure you are always starting with that pre-image. And from the pre-image to the image, it is turning 120 degrees as labeled. Is that a clockwise or a counterclockwise turn? Do we know the way a clock works? Is that clockwise or counterclockwise? There's a clock right up there. What do you think, Caitlin? Yeah, that one's counterclockwise. We are going to always assume that our rotations are counterclockwise unless otherwise stated. The reasoning for that is just because if we think about like a coordinate plane, you know how coordinate planes have 4 quadrants? The quadrants in a coordinate plane also go counterclockwise. So we start in the top right with quadrant 1, then go to the top left, quadrant 2, bottom left, quadrant 3, bottom right, quadrant 4, also a counterclockwise rotation. So that's why all of our default rotations are going to be counterclockwise. Any questions on that? Okay. So, one of the easiest ways to figure out a rotation, 90, 180, or 270 degrees, is to use our transformation functions. Remember, sometimes we like to memorize those things. So let's take a look at each one of those turns and figure out what the transformation function is. In this first one, determine the center and the angle of rotation. This one's nice and easy. Obviously, they're all labeled for us. Our center is called O, which stands for origin, by the way. And that angle of rotation in this problem is 90 degrees. Now, the transformation function, if you recall how a transformation function is written, we always start with x, y, because that represents our pre-image, and then we draw an arrow, and then we'll have something representing how the pre-image relates to our new image. For a 90-degree turn, we flip the x and the y, and we make the y value negative. So you flip x and y, the first number becomes negative. That's true for every counterclockwise 90-degree turn. You can use that rule. That is something that you can memorize. That is something that I like to have memorized. The next one is 180. So same things to start with. Our center is at O. That's our origin. This time our angle of rotation is a 180-degree turn. And our transformation function looks like xy. And our new image for 180-degree turns is to take the negative form of both x and y. So instead of xy, I have negative x, negative y. A question that came up on Tuesday when we talked about this is, what happens if my number is already negative? Well, if you put another negative in front of a negative, double negatives always become positive. Shocker. Questions on that one? The last one we have is a 270-degree turn. So that's 3 90-degree turns. Determine the center and angle of origin, center and angle of rotation. My center is O. My angle of rotation is 270. And my transformation function looks like xy becomes this one. Again, we're going to flip the x and the y values, but this time the x becomes negative. So 90 and 270, very, very similar, except one makes the y negative, one makes the x negative. These are things that you can choose to memorize, but of course we have ways to do them without memorizing these transformation functions. It's all up to you, whether you're more of like a technical kind of person or if you're really good at visualizing. I'm not good at visualizing these rotations sometimes, so I prefer to have these memorized. Are we ready for some examples? Determine the measure of the angle of rotation for the figures below. These kinds of problems where you have the image and the pre-image drawn for you, super easy. Let me show you what we're going to do. I'm going to mark my origin because the origin is the center of rotation in all of these problems. So I'm going to put a big dot right there in the center to show where the middle is. And then I'm going to pick a pair of vertices. It doesn't matter whether you decide to do the P's, the Q's, the R's. I'm going to do the R's, and I'm going to connect R to the origin, and I'm going to connect R prime to the origin. Remember that when we are doing these rotations, I am always starting at the pre-image. The pre-image is the one that does not have a tick mark, so I should start here at R. And the second thing we need to remember is we are going to move counterclockwise. So from R to R prime, that's the angle I'm measuring. And it looks pretty straightforward too. As long as we're remembering which direction we're going, hopefully we can see what's the measure of that angle. They're increments of 90 degrees. So that one should be 90 degrees. Do we all see that? No matter what pair of vertices you pick, you should get a similar picture. So if you picked to do the Q's, you would also see from Q to Q prime that 90 degree angle. If you picked the P's, from P to P prime, you'd get that 90 degree angle. Let's look at another one. In number 2, I have 4 vertices, T, S, U, and X. So doesn't matter which one we pick. I'm going to put a circle, a dot right in the origin. Let's pick, let's pick the T's. I'm going to connect T to the origin. I'm going to connect T prime to the origin. I need to make sure that I'm going counterclockwise, starting at my pre-image, which is the one with no tick marks. So starting down there, going counterclockwise this way. So I don't want to see any lines going this way. That's not the same. And this is a straight line. So hopefully we see this is a 180 degree turn. Good. Last one, number 3, same deal. Let's put a dot in the origin. Let's pick, let's go with N. I'm going to connect N to the origin and N prime to the origin. Here's where it gets tricky. Because you see that angle right there, you're automatically going to think, oh, that's 90 degrees. It looks like a right angle. However, remember that we are starting with the pre-image, which is N, and we are going counterclockwise this way. So we should not be counting this angle right here. That's bad. But from N to N prime, counterclockwise, that's over 180 degrees. That's a 270 degree turn. Be careful. That problem gets messed up all the time. Any questions on these? Okay, flip it over. I'm going to show you how we can do this, graphing these coordinates of the image in 2 different ways. Determine the coordinates of the image given by the rotation. Graph the image. The rotation is 90 degrees about the origin. What I like to do, of course, is I have these memorized. So I go back in my memory bank and I think, okay, what is the transformation function for a 90 degree turn? And that's when we take the x and the y and we flip them and the y value becomes negative. Maybe it's going to take you a second to remember that. Maybe it won't. I'm going to write that down over here. That's my transformation function. So what I would do is I would take all the coordinates, b, x, n. Let's start with b. B looks like it's at -4, 1. So to get the new coordinate for b prime, I would flip the 1 and the 4 and make the first number, the y value, negative. So my new point, b prime, would be located at -1, -4. Let me graph that on here. -1, oops, is right here. Questions on that? Now, I know some of us do not like memorizing things, and I know some of you are much better at visualizing these kinds of things than I am, so let me show you how we can do it just with this graph. So if I take a look at my origin, because all of my rotations should be about the origin, instead of connecting B to that origin with a straight line, I'm going to do it with like left and right or up and down lines only. So I'm going to connect it like this. I'm going to use a different color, actually. Do we see that? Now, if I take that shape, that little L shape that I just drew, and I rotate that L shape 90 degrees counterclockwise, look at what happens. I get to B prime. And I can do that for X and for N as well. So let me erase this, and I'll show you what it looks like for X. So for X, here is my shape. I'm going to take that shape, and I'm literally going to imagine that I turn it 90 degrees. Some of you are going to be much better at this than I am. I messed it up first hour. But that's where X prime would go. Okay? Same thing for N. Maybe this one's a little bit easier to see. I'm going down 5 in this direction and over 4 in this direction. And that is where N prime would go. So just like we did with reflections, there are multiple correct ways that we can get these points. It is just dependent on what you like best. Any questions on that? Any questions on any of rotations? Because we're going to move on to a little subtopic now. We're good? Oh, sorry, I missed one. Determine the function rule for a 360-degree turn. Let's think about that transformation function. If it starts with the pre-image xy, and then I rotate that 360 degrees, what does my new image look like? 360 degrees is a full turnaround. So my new image should look like, yeah, xy, exactly the same. Same. Just a little hint. So if you ever see 360 degrees, nothing happened to it. It went all the way around and came right back to where it was. Okay, that's besides the point. New topic, real quick, little tiny mini thing. Line of symmetry. A line of symmetry is anything that splits a shape in half and it is symmetrical on both sides. Now this gets a little bit tricky because you have to imagine lines of symmetry where we're folding a piece of paper and all the edges and all the corners line up, okay? So what we're going to basically be doing is taking a look at different shapes and figuring out where the lines of symmetry are and how many lines of symmetry, if there are any. So sometimes we get nice, easy shapes like this, like an X, right? I know that if I split this shape in a few different ways, I can get some lines of symmetry. If I go right down the middle, that's a line of symmetry. I could fold that X over itself and all the sides would overlap. I could go this way. Any other ideas? How about if we fold straight through these legs? Okay, that way I would get a symmetrical shape on either side. This way I would get a symmetrical shape on either side. So in this particular example with this X, there are 4 total lines of symmetry that we could draw. Every single way we fold that shape, that X up over across those lines, the edges and the vertices would line up. What about the check mark? Are there any lines of symmetry in that check mark? There is not a single way that I could draw a line through the check mark and make all the edges line up together. So this one is none. What about this parallelogram? Can we draw lines of symmetry through the parallelogram? I need you to literally imagine that you are folding this piece of paper. You could probably fold your piece of paper over this parallelogram and see what happens. I'm going to give you some suggestions. Try folding it this way. See if you can get those parallelogram corners to line up with each other. What you're going to notice is that this corner is going to end up somewhere over here. And this corner is going to end up somewhere over here. That's telling me that if I try to split that shape diagonally, my corners are not lining up. That's not symmetrical. If we do the same thing this way, we're going to see the same thing. Our corners are going to line up here and here. So are there any lines of symmetry in this parallelogram? No. Even though this parallelogram looks very symmetrical, it is not. This is one that they like to use a lot of the time because it's tricky. So just keep in mind maybe that parallelograms like these are not symmetrical. And then a nice easy one. I have this nice rounded shape. There is only one way I can fold this shape to make it symmetrical on both sides, and that is straight down the middle. Any questions on this?